Friends, once again welcome to another video from iCampSA. Today we're going to be doing a past paper question. This one is from 2019, and we will be answering some questions which are focused on the functions, of which has been the topic we have been covering recently. So this is part of that series. Anyway, let's get into it. So for 2019, for question 5, we're given the following. So question 5, it reads as follow. Sketch below are the graphs of f at x is equal to k over x plus q. K over x plus q. What does that tells us? We see the x there in the denominator, which means we are dealing with the hyperbola. And we have the graph of g at x is equal to x plus 2, and then just by the form of that we can see that this one is a straight line. And then the equation of the horizontal asymptote of f is equal to y is equal to 1. The horizontal asymptote y is equal to 1, and remember that from the equation which variable is for the asymptote, and that is the q variable, which represents the asymptote. Therefore q is equal to 1. Basically graph g cuts the x-axis at b, and we see that this graph they also intersect there at b. So graph f and g intersects at a and b. And remember, when the graph intersects, what do? Let's say we were asked to find the coordinates, or the coordinates where these two graphs intersect. What do? We simply equate the two equations and solve for the x and the y values. Okay, so that is that. Let's get into the question. Okay, so for 5.1.1, we are asked to write down the value of q. What is q? Q is the asymptote. Q is the asymptote of the hyperbola, or the hyperbolic function. So this is our 5.1.1. We are asked to write down the value of q. So q is equal to 1, and the reason we said it's the horizontal asymptote. Okay, and then next for 5.1.2, we are asked to write down the domain of f. And when we are looking at the domain, what are we concerned with, or what are we actually dealing with? We are looking at the x values. And when you look at this graph, it exists for all the x values except where x is equal to 0. So for the domain of q, we're gonna say x is the element from negative infinity to 0, union from 0 to positive infinity. And we use round brackets, and remember that round brackets, it means that number is not included. So in this case 0 is not included. Or what we can say is that x is the element of real numbers, but x can never be equal to 0. So we can also represent our domain in that form. Okay, and then for 5.2.1, determine the equation of the line of symmetry of f, the line of symmetry of this graph with that has a negative gradient. Remember that the line of symmetry for the graphs passes through the horizontal asymptote. So the one that we're looking for is gonna be this one, and then that one will be the one with the negative gradient. And then if we are also asked to find that other one, is gonna be this one with the positive gradient. Okay, so for 5.2.1, the line of axis of symmetry with a negative gradient, 5.2.1 is gonna be what? It's gonna be x, it's gonna be y is equal to negative x plus 1. Y is equal to negative x. That negative x stands for the negative radiant, and then that plus 1 is the y-intercept, which takes place there at the asymptote. So y is equal to negative x plus 1. Okay, and then for 5.2.2 we also find the equation of f. The equation of f. Okay, let's see how many unknowns do we have for f. So for f, we have k and q. We already have q, so the only unknown we are left with is what? Is k. But then we also need a coordinate, x and y values that we can use to solve for the value of k, and then what do we know about this function is that it cuts the x-axis at b, which also is the x-intercepts of the function of g. So we can use that to find the coordinates of b. This is gonna be 5.2.2. What is the equation of g? Is g at x is equal to x plus 2, and then for the x-intercepts, we let y equal to 0. So we're gonna have 0 is equal to x plus 2. Therefore x is equal to negative 2. Which means that the coordinates of b, therefore the coordinates of b is negative 2 and 0. Okay, and the b coordinates is shared between these two graphs, among these two graphs, which is the graph of f and g. So b is the coordinate that we find on the function of g and also on the function of f. So we can use it to solve for q. To solve for k. So in order to solve for k, we're gonna say f at x is equal to k over x plus q, which is equal to 1. Let's substitute the values that we have. We're gonna have 0 here is equal to k over what is x minus 2 plus 1, the q. We take the 1 to the other side, we're gonna have a negative 1 is equal to k over negative 2. Therefore k is equal to negative 2 multiplied by negative 1 is going to be a positive 2. Okay, once we have that, therefore the function of f, or the equation of the function of f, is going to be f is equal to 2 over x plus q, and we see that the value of k is positive, which is corresponds with the function that the sketch that we are given there, since it has the branches in the first and the third quadrant. If the value of k was negative, the function was going to have its branches in the second and the fourth quadrant. They were going to be there, the branches of that function. Okay, and then next we have to find the coordinates of a, the point of intersection of f and g. And I've already mentioned at the beginning of this video that if we are ever asked to find the coordinates where two functions intersect, what do? We simply equate the two equations. So let's go ahead and do that. This is gonna be 5.2.3. so for 5.2.3, let's say at a, f at x is equal to g and x. Therefore what we can do is to equate these two equations. We're gonna have, I made a mistake here, it's plus 1 not plus q. So it's 2 over x plus 1 is equal to, what is the function of g? The function of g is x plus 2, if I remember well. Yes, it's x plus 2. And then let's solve for x. Once we are here, let's solve for x. So we're gonna have let's take 1 to the other side. We're gonna have 2 over x. 2 over x is equal to x. 2 minus 1 is gonna be, we take the 1 to the other side, it's gonna be x plus 1, x plus 1, and we multiply by x on the both side. We're gonna have 2 is equal to x squared plus x squared plus x. Maybe let me do it like this. We're gonna have x into x plus 1. Therefore 2 is gonna be equal to x squared plus x, and then let's put everything on the same side. We're gonna have x squared plus x minus 2 is equal to 0. We open 2 brackets now. We factorize to find the roots. Okay, we're gonna have x and x. We're gonna have 2 and 1 and a positive and a negative. Therefore x is gonna be equal to 1, or x is gonna be equal to negative 2. X is gonna be equal to negative 2, and we already know that x is equal to what is this thing? Negative 2 goes with what? With b, with the b coordinates that we calculated there. But also, if we come here, we can see that b is to the left of the y-axis, so it's on the negative side of the Cartesian plane. So a goes with 1. Therefore the coordinates of a are gonna be, we have only calculated the x coordinates, so for the y coordinates we can just use any equation between the equation of f and g to find the corresponding y coordinates. Let's use the equation of f. I'm gonna say f at 1 is equal to 2 over 1 plus 1. Yes, okay, 2 over 1 plus 1 is gonna be, therefore f at 1 is gonna be 2 over 1 is 2 plus 1 is 3, is 3. Okay, and then what do we have here? Therefore the coordinates of a are gonna be 1 and 3, 1 and 3, both positive. Okay, coordinates of a. Okay, so that's for question 5. Let's go ahead and do question 6. Yes, question 6. Okay, so the graphs defined as g at x is equal to ax squared. What does that tells us? We have a to the coefficient of x squared. That already tells us what we are dealing with. We are dealing with a parabola, and that q is our turning point. The q is the y-intercepts and the turning point, and f at x is equal to k to the exponent x. We see x there as an exponent, which means we are dealing with what? With an exponential function, minus 4. That minus 4 is gonna be what? It's gonna be our horizontal asymptote, because the exponential function has a asymptote. Both pass through -2 and 0 on the x-axis. Okay, both pass through -2 and 0 on the x-axis. Okay, the y-intercepts of g is 0 and -5. It's 0 and -5. What did I say was the y-intercept on the equation? Is that q is the y-intercept, and it also a turning point. It is also a turning point. Okay, so first thing first, for 6.1 we can answer our questions now. For 6.1, write down the equation of the asymptotes of f. The exponential function, the equation of the asymptote of s, we're gonna have y is equal to -4. This is your horizontal asymptote. And then we are asked for 6.1.2 to write down the value of q. What is q? Q is the turning point, which is given by the y-intercept. So we're gonna have q is equal to -5. Q is equal to -5. Okay. The coordinates of the other x-intercept of g, So when we are dealing with a parabola and it is given in this format of ax squared plus q, the y-axis also acts as a axis of symmetry. So essentially the function is mirrored about the y-axis, So and we have been told here that both functions pass through -2 and 0 on the x-axis. So if it passes through -2 and 0, which is to the left side, that means if we mirror that about the y-axis, it is also going to pass through 2 and 0 on the right side. So the coordinates of the x-intercept of the other x-intercepts of g for 6.1.3 are going to be 6.1.3. the coordinates are going to be 2 and 0. The other x-intercept is going to be 2 and 0. Okay, and then for 6.2, we are asked to determine the equation of 6.2.1, the equation of g. What is g at x? G at x is equal to ax squared plus q. We have already determined the value of q. And we have the coordinates of the x-intercepts we can use to solve for a. So we can say g, let's use just the coordinates we have just written right above, which is 2 and 0. So we know that g at 2 is what? Is 0. So we're gonna have 0 is equal to a into 2 squared. What is the value of q plus q, which is -5. Let's solve for a. So put the -5 on the other side. We're gonna have a +5 is equal to a to the power of 2 is gonna be 4. Let's divide by 4 on both sides. So a is equal to 5/4, which means that the equation will therefore be g at x is equal to 5/4 x squared minus 5. Okay, then we see that the value of a is positive. So if we were to be asked to sketch this function and we have a positive value of a, it means the function will be facing upwards. Maybe let me put a note there. Let me say positive a equal to face up. It's facing upwards. Okay, and then from there we're asked to determine the equation of f, the exponential function. What do we have missing there? Is the value of key. Okay, this is 6.2.2. So f at x is equal to k to the power x minus 4. Okay, so in order to find the value of k, we need to substitute a coordinate. We know that k passes through what? K passes through -2 and 0. -2 and 0. So we have to substitute that in order to solve for k. So f at -2 is 0 is equal to, this is equal to k to the power of -2 minus 4. Let's put my 4 on the other side. 4 on the other side, we're gonna have 4 is equal to 1 over so this is gonna be 1 over k to the power of 2. Okay, so we are looking for k. What do we have to do here? We have to introduce a square root on both sides. So k will be, let's see, k will be, we introduce a square root on both sides. We're only gonna consider a positive square root because for negative roots, they really don't work out for what you call this thing, for the exponential functions. If we have a negative value of k, what then happens is that it doesn't become an exponential function. I don't think it becomes a function at all. Okay, but yeah, we're only going to consider a positive root. So we're going to have 2 is equal to 1 over k. Therefore, k is equal to 1 over 2. K is equal to 1 over 2. K is equal to 1 over 2. And what we're looking for? A equation of f. So therefore, f at x is equal to 1 over 2 to the power of x So we have a value of k that is greater than 0 but less than 1. So it's a fraction basically. What does that tell us? It tells us that we are essentially dealing with a what? A decreasing function. It tells us that we are dealing with a decreasing function. Decreasing function. So you should know this thing just in case you are asked to sketch the function. If the function was greater than 1, it was going to be an increasing function. What is a decreasing function? A decreasing function is a function that the values, the y values decreases as the x values increases, so they oppose. And an increasing function is the one that when the x values increases, also the y values increases. Okay, that is that. Okay, and then next, calculate the y-intercept of f. The y-intercept of f. What is f? F is there. Is the exponential function. So this is 6.3. For 6.3, what do we do in order to calculate the y-intercept? So for y-intercept, let x equal to 0, and then let's solve. So f at 0 is gonna be 1 over 2 to the power of 0 minus 4. So f at 0, what is 1 over 2 to the power of 0? Anything with raised to the power of 0 is going to be 1 minus 4. Therefore, y is equal to -3. That choose the y-intercept. Y is equal to -3. Okay. And then next, on the same set of axes, sketch the graphs of G and F. Show all the intercepts with the axes and the asymptotes Okay, so we are now asked to sketch these two functions for 6.4. I'll just come here to this new page to this new page to make things easier. So for 6.4, let's see. We have the intercepts at -3 and -4. We have the asymptotes and the turning points at -5. Just want to see what intervals we should use. I'm thinking of 2, but let's use okay, so 1 2 3 4 5 6 7 1 2 3 4 5 6 1 2 3 4 5 1 2 3 4 5. Okay, let's calibrate our axes. This is y and x-axis. We're gonna have 1 2 3 4 5 -1 -2 -3 -4 -5. We're gonna have 1 2 3 4 5 and 6. We're gonna have a -1 -2 just write -6 -2 -3 -4 -5 -6. Okay, let's start with the parabola. With the parabola, which is the function of g. For the parabola, we have a turning point where at -5, so it's -5 and 0. That is the turning point here. It's -5 and 0. And then what else? For the function of g, the intercept, we have 2 and 0 and -2 and 0. We have there's intercepts here. Okay, that is what we need for the parabola. So it's gonna be facing up, we know that. Yes. Okay, perfect. Okay, that is the g function, the parabola. That is the parabola, that is the g function. Okay, we'll label it afterwards. Let's come here and sketch the function of f. It has the asymptote, horizontal asymptote, where at -4 we start by drawing that. At -4, just take your ruler and draw dotted lines. At -4, that is where your asymptote will be located. And then we have key points here. The function has the y-intercepts at y is equal to -3, and it has the x-intercepts where at -2 and 0, -2 and 0. So here, that is where it has the x-intercept. Okay, and then our function is gonna be a decreasing function. And we see slightly so. Yes, so the function is gonna be like that. Okay, this will be our function, and we were asked to label the function. So we have the asymptote where y is equal to -4, and then let's label the intercepts, the axes. We're gonna have 0 and -5. That one is for the parabola, and here we have 2 and 0. They both cut through -2 and 0, and then the y-intercept of the exponential function is 0 and -3. 0 and -3. What else? Okay, and then the equations for the parabola is the f function. Sorry, it's the g function. G at x is equal to 5/4 x squared. G at x is equal to 5/4 x squared minus 5. X squared minus 5. And then for the hyperbola, we have f at x is equal to 1/2 to the power of x minus 4. Okay, and that is how you will go about sketching your function. This is how it will come out. Everything corresponds. The value of a for the parabola is positive, so it's facing upwards. We have a turning point at -5. And then for the exponential function, we have the value of k between 0 and 1, between 0 and 1, which is a fraction, so it's a decreasing function, and we can see that the function is in fact decreasing. And then that was, let's see, that was 6 marks, and that's how we'll go about that is how you'll get your 6 months. Okay, so that's for this video. Until we meet again, I wish you good luck and good study.